36-year-old probe is now sailing the uncharted waters of a new cosmic sea, and it has brought us along for the journey.
It appears as though outer space is a vast, uninhabited void, lacking any traces of extraterrestrial civilizations resembling our own. This implies a silent cosmos, where exploration has been a unique endeavor for humanity. However, recent revelations may challenge this perspective. The Voyager mission, embarking on a journey into interstellar space, has uncovered fresh insights into the mysteries beyond our solar system. Within the distant realms of space, Voyager probes have encountered phenomena hitherto unknown to humanity, sparking more questions than providing answers. So, what remarkable and perplexing discoveries have the Voyager spacecraft made? What if we are not the exclusive inhabitants of the universe? What lies ahead for these NASA spacecraft in the times to come? Let's delve in to find out. It has been more than 44 years since Voyager 1 embarked from Earth, yet it continues to transmit data. Researchers detected an unusual cosmic hum, a newfound signal markedly different from previous records. Despite the probe consistently relaying data before, we now had the unprecedented opportunity to glimpse beyond our solar system in human history. This signal emanated from a distance of 14 billion kilometers away from Earth, maintaining a steady 3 kHz frequency for over 3 years. It stands as the most enduring and uniform hum ever observed by Voyager 1, becoming apparent only after the spacecraft covered a considerable distance. The origin of this ethereal sound puzzled scientists. Many posit that the hum stems from plasma waves coursing through the depths of the universe. Plasma, a fundamental building material present in and emitted by virtually all cosmic objects, is likely responsible for this phenomenon. The astonishing aspect is that this sound remained virtually unchanged even as the probe traversed an additional billion miles. Some experts entertained the idea that an unknown energy source might be behind this remarkably constant hum. However, the question arises, if space is devoid of sound, how does this phenomenon persist? Genuine sound diminishes rapidly in the vacuum of space due to the insufficient presence of particles for its transmission. Even phenomena like collisions of black holes or massive supernova explosions find no medium for their sound. Among the various electromagnetic waves capable of traversing a vacuum seamlessly, radio waves stand out. Although imperceptible to our human ears, scientists have devised a method to convert these signals into audible sounds, allowing us to hear the message transmitted by Voyager 1. NASA has encountered other peculiar noises that puzzled the scientific community in the past. In 2007, researchers stumbled upon preserved data from previous years, revealing something unusual. This revelation pertained to fast radio bursts, rapid bursts lasting merely a millisecond each. Subsequently, scientists actively sought additional instances of FRBs and discovered a multitude of these swift bursts. Is it conceivable that an advanced extraterrestrial civilization is attempting to communicate with us? Who can say? Perhaps this wasn't intended for our observation and hearing. Some astrophysicists posit that these fast radio bursts have origins in black holes or massive neutron stars, while others entertain a more intriguing hypothesis about the broader universe's activities. They propose that these signals are potent extraterrestrial radio waves designed to power their light-propelled spacecraft over vast distances, but were inadvertently redirected. While this theory may be a stretch, there's a consensus on both sides that these FRBs must emanate from an inconceivably distant source, billions of light-years away from our galaxy. Although our technological capabilities do not extend to such extreme distances, our mastery of our own solar system surpasses that of interstellar space. NASA's Voyager 2, arriving in interstellar space in November 2018, followed in the footsteps of its twin, Voyager 1, which embarked on this interstellar journey over 6 years earlier. Voyager 2 has provided astronomers with fresh insights into the nature of our solar system's heliosphere through its data. Similar to its counterpart, Voyager 2's primary mission was to explore and examine entities beyond our solar system. The probe closely investigated all 4 of the solar system's largest planets: Jupiter, Saturn, Uranus, and Neptune. The revelation of volcanoes on Jupiter's moon Io and the determination that Europa likely harbors an ocean astonished scientists when the probes made these discoveries. Voyager 2, in every aspect, achieved success, delivering breathtaking views of the entire Jovian system and time-lapse movies of Jupiter derived from its captures. unveiling the planet's changes since Voyager 1's visit. Its images of Io depict alterations in the moon's surface, capturing ongoing volcanic eruptions. The probe transformed the streak observed by Voyager 1 on Europa into a series of fissures within a thick, unexpectedly smooth icy layer. It also unveiled an additional element of the planet's rings and identified a 14th moon. Voyager 2 delivered the exclusive close-up perspectives of Uranus and Neptune ever witnessed by humanity. Scientists persistently extract captivating new insights into the cosmos through the analysis of Voyager's data, which spans decades. Being the third spacecraft to reach Saturn, Voyager 2 afforded yet another intimate view of Saturn and its moons. As the initial human-made object to traverse Uranus, Voyager 2 discerned 10 previously unknown moons during its flyby. These newfound moons were bestowed names like Puck, Portia, Juliet, Cressida, Rosalind, Belinda, Desdemona, Cordelia, Ophelia, and Bianca, all distinctly referencing Shakespearean themes. Beyond the pre-existing 9 rings, Voyager 2 identified 2 novel rings and a magnetic field skewed at a 55-degree off-axis and off-center orientation. At a depth of 497 miles 800 kilometers, the probe unveiled a seething ocean of water. Notably, the opacity and thickness of its rings displayed considerable variability. Furthermore, Voyager 2 captured striking images of Miranda, Oberon, Ariel, Umbriel, and Titania, the 5 largest moons of Uranus. The spacecraft achieved unprecedented proximity in its nearly decade-long odyssey, flying by Miranda at a mere distance of 17,560 miles. The imagery of this moon exposed an unconventional object marked by a disarray of peculiar features lacking an apparent rhyme or explanation. Uranus itself seemed to lack distinct features. While passing by Neptune, the spacecraft unveiled 6 new moons: Proteus, Larissa, Despina, Galatea, Thalassa, and identified 4 previously unknown rings encircling the planet. With winds raging at 680 miles 100 kilometers per hour, the planet displayed more activity than initially presumed. Despite its distinctive blue hue attributed to abundant methane, hydrogen emerged as the most prevalent atmospheric element. The lesser dark spots, the great dark spots, and Scooter 3 notable features within the planetary clouds were meticulously revealed through these captivating images. Voyager 2 captured detailed images of 2/3 of Triton, Neptune's largest moon, exposing the solar system's coldest planetary body and a nitrogen ice volcano on its surface. Stunning photos of its southern hemisphere showcased an unusual pitted surface reminiscent of a melon. Voyager 2's planetary encounters, spanning an impressive 12 years in deep space, concluded with a flyby of Neptune. Following its traversal through the system, it embarked on a trajectory below the ecliptic plane, venturing out of the solar system. In contrast, these probes haven't halted their exploration of the solar system's outer regions. Voyager 1 and 2 are still operational today, marking them as the world's longest-running and farthest-reaching space missions. Despite following distinct trajectories, both spacecraft are propelling themselves out of the solar system, and there is a considerable amount of tasks lying ahead of them. Recently, the twin probes unveiled a surprising finding. The solar wind moves slower than anticipated at the solar system's frontier. Analyzing data from both probes has enabled astronomers to compare, contrast, and validate results regarding the boundary between our solar system and interstellar space. If you're wondering about the end of Voyager 1 and 2, these probes have maintained near constant communication with NASA for over 44 years since their launch. As per mission planners, communication will persist until the probes either fail or lose power. Until 2025, it is expected that both probes will be able to keep at least one scientific instrument operational. Even beyond that point, NASA plans to receive engineering data from the probes until 2035 when they surpass the range of the Deep Space Network antennas. Regrettably, this implies that until they reach their next destination, the interstellar mission won't be able to relay observations. From the mission's outset, NASA foresaw this inevitable moment. For certain astronomers, the notion of these probes embarking on a solitary journey out of the solar system proved emotionally challenging. Carl Sagan, deeply moved by the concept, collaborated with NASA to create a comprehensive cultural component for the trip in case future extraterrestrials or space-faring Earthlings encountered one of the Voyager probes. A committee, led by Sagan, curated the contents of the golden record on each spacecraft, functioning as a terrestrial time capsule. These messages to the cosmos encompass images, sounds, global music, and greetings in 55 languages, collectively representing Earth. Even as communication from the Voyager probes may eventually cease, there's a possibility that this won't mark their ultimate transmission on the stellar odyssey. As per Carl Sagan, billions of years ahead, our sun, transformed into a distended red giant, will have turned Earth into a charred remnant. However, the Voyager record is anticipated to endure in some distant sector of the Milky Way galaxy, preserving an echo of an ancient civilization that thrived, perhaps preceding ventures to grander accomplishments and other realms. Thanks for watching today's episode. We will be back to you with another amazing video. Until then, goodbye and peace.
Yeah.